This lesson and the topic is solving inequalities in one variable. Most of the inequalities we're going to be solving here are going to be nonlinear ones. So we're going to look at primarily absolute value equations or inequalities, and we'll also look at polynomials. So the first thing is you want to do is seeing about just solving the equation first. So change to equals and make it into an equation. Because we know how to work with these. So we just have to go through our steps, and I'm going to subtract 3, and then I'll multiply both sides by -1. We want to isolate the absolute value. Now, watch out for special cases. If this was a negative, it would be a special case, because once I get the absolute value by itself, then I want to make sure I don't have this thing equaling a negative. If it's equal to a negative, then I've got a special case, and we'll look at that one a little bit. Okay, so this is not a special case. So now I'm going to do my two cases. Either to get out 13 out of an absolute value, either the inside of this equals 13 or the inside of this equals -13. So those are my two choices. Now I'm going to solve each of these individually. So I'll subtract 5, that gives me 8, divide by -2, and that gives me -4. Subtract 5, you get -18, divide by -2, I'll get +9. Okay, so now I'm going to go to the graph, because the easiest way to solve these when they're inequalities is by using a graph. So I just have a number line. I plot -4 and 9, and since I don't have equals on my problem, I'll use an open circle for both of those. And now I've got 3 regions. So I'm going to test each of these regions. So what's going to happen is I'll usually either go like true, false, true, or false, true, false. That's typically what's going to happen on these, but we'll test each of the regions just to make sure. So I'm going to test the one in the middle because that's the easiest one to do. I'll plug in 0 into my equation, and when I plug in 0, I get 3 minus 5 minus 0. So I get 3 minus the absolute value of 5. Well, 3 minus absolute value of 5 is 3 minus 5 is -2. -10 is not greater than -2. That's a false statement. So this section in here is false. Now, I could plug in a point above 9, say like 10. If I plug in 10 in the equation, I get 5 minus 20 in the absolute value. This gives me -15, but the absolute value of -15 is +15. So I get 3 minus 15, that's -12. -10 is bigger than -12. That's a true statement. So we kind of anticipated. This one's false, this one should have been true. Likewise, this one over here should be true, as long as it's not a special case. That's not a bad idea to check anyway. Okay, now I'm going to test by plugging in like -5. Plug in -5, I get 5 minus 2 times -5, so that would be 5 plus 10. Absolute value of 15 is just 15. 3 minus 15 is -5. -10 is in fact greater than, is -12. -10 is in fact greater than -12. That's true. What I'm going to do now is shade my true sides. So that part was true, and that part's true. Now, writing my final answer. This is represented by x is less than -4. This one, x is greater than 9. When we use inequalities, we just kind of point our arrow in the same direction that the shading goes. And work with the interval, that's a little bit different. Now, we connect the pieces with the word or. You can also use interval notation. Then I say this is going from -infinity to -4, or 9 to infinity. And another symbol we can use is the symbol union. But if you want to write the word or here instead, that's fine if you want to use interval notation. But you will see some books will use the symbol U, which stands for union, which is the same thing as like using an or. Okay, now watch out for the special cases. So I'm going to look at a case where we end up getting that negative. Well, I'm going to subtract, take my equation, change it to equals, I'll subtract 22, and all of a sudden I get an absolute value equaling a negative. That tells me it's a special case. So what's going to happen, either it's always true or never true. So all I got to do now is just test a single value to see if it's true or false. Well, the easiest thing to do is plug in 0. So I'll plug in 0, and I get 22 plus the absolute value of negative 2. This gives me 22 plus 2 is 24. 24 is greater than 17. That's true. Therefore, it is always true, which means I'd be shading everything. So when you write your answer for this one, the easiest way to say it when it's always true is all numbers. If it's never true, say no solution. Okay, let's take a look at another one that's not with absolute value. Let's look at polynomials. So now we have an equation, and it's a polynomial. 2x cubed is less than or equal to 50x. Now I can change to equals right now, or if I wanted to, I'm going to have to factor it, so I'm going to move the 50x to the other side. Now I could change to equals and factor at the same time. So I can do it in a couple steps if I like. I could factor out a 2 and an x. So I have 2x times x squared minus 25. X squared minus 25 factors to x plus 5 and x minus 5. So I look for all my solutions. I get x equals 0, x equals negative 5, and x equals positive 5. Put my number line out. I have equals, so therefore I'm going to have solid dots for each one of them. So there's at 0, negative 5, and positive 5. Now what I'm going to do is test each one of these regions. Now unfortunately I can't use 0 as one of my test points, so I'll have to choose something different. So I'm going to plug in 1. That would be my easiest number to start with. If I plug in 1, and I can plug it into this equation up here, the original, 2 is less than or equal to 50. That's true. I could plug into this one. 2 minus 50, that's negative 48. That is less than 0. That's also true. So you can actually use the original one, or if you kept the inequality, you can use a secondary one. So that tells me this section here is true. So I'm just plugging in my head because it's going to be easy enough to do. Now what's typically going to happen is you're going to see it alternating. So since this one's true, most likely this is going to be false, this one's false, and that one's true. Well, I could just test it by testing other numbers if we want to make sure. So if I want to plug in 6 or plug in 10, maybe 10 might be easier. If I plug in 10, I have 10 cubed, that's 1,000. 2,000 is not less than 500. So that one's false. If I plugged in like negative 1, I have negative 1 cubed is negative 1, that's negative 2, is not less than negative 50. That's false, but I anticipated that. It should be alternating. It doesn't alternate if you get a repeat of a factor. So if I get 2 answers of x equals 5, then I'm going to get repeats. But you still can go over and test it. I'm going to plug in like negative 10. Now this one should come out to be true. Negative 10 cubed is going to be negative 1,000. So I get negative 1,000 times 2 is negative 2,000. Negative 500. Negative 2,000 is less than negative 500. That's true. So I'm going to shade my true parts. Now when I write my answer, this part is x is less than negative 5, less than or equal to negative 5. When I have an interval, my lower number is 0, my higher number is 5, so I go 0 and 5, x is in between, has equals on both of them, and I always use less thans. I connect any pieces I have with the word or. If you want to use interval notation, you could say negative infinity to negative 5, close bracket, 0 to 5 with closed brackets for the closed circle. And you can use the word or here if you like using interval notation, or if you want, you can use the symbol union. Okay, so it gives you the basic ideas about putting it together. Remember, use your graph, makes the problem a lot easier than going through lots of different cases.